What do they actually represent? A router represents a layer 3 device. Then, in 3 layers, we have an important parameter called IP. A switch represents a layer 2 device. On the second layer, which is the data link layer, we have an important parameter called the MAC address. So you need to put these 2 parameters and 2 devices working on different levels to match. That is, for a device on the link, it cannot cross this link. That's what we just said. Is a data to the network connected to the switch. The switch can be judged. Information about the MAC addresses that are now connected to these terminals. But once you get rid of the whole switch now, as long as you go through a router's interface, MAC addresses are relatively useless. That is, the MAC address is to work within our scope. I'll be more straightforward. In the future, if you this PC, I want to find the server of company C in region B. You can't find it by relying on the MAC address. That is to say, the MAC address cannot access a remote device. It can only access the device in front of it and connect it through the switch within a network. Such an address, it can be found. Broadly speaking, it cannot provide address identification. Then now, there is no way for us to complete the corresponding functions on the second floor. We're going to look up for the second floor. One of the first functions it can perform. We can find bugs, implement an error detection. If there is a problem with this data, I lost this data, but I can't go any further. What is the next step? For example, I now send a message to the peer. Then my message is damaged in the middle. But for the sender device, this data has been sent. Some device lost the data in the middle. Then this device needs to notify me. This data is not passed to the destination, but for the second floor. It can only be responsible for throwing this data away. It has no way to notify the original device. So this is a function that the second layer cannot complete. This is the first one. The second one is like what I just told you. There is no way for a MAC address from our macro, or to analyze the address information from a global perspective. That is, its scope of action is relatively narrow. Precise but too small. What kind of address do we use for identification? We are on the third floor. There will also be a parameter on the network layer. It will also carry an address information. IP address. So for IP addresses, the scope in which it takes effect. Not on a link. It does not take effect within the scope of such a link. Rather, in the process of passing all data as a whole, it will take effect. But for our MAC address, our data throughout the transfer process, MAC addresses are subject to change. For example, you are now from region A. Send a courier to area B. For example, you are in the first middle school in area A. It is the second middle school in the province of B region. So, for example, there is a man named Tom. Another person's name is Mary. Tom from the first middle school, Mary from the second middle school. This is actually the equivalent of an IP address. Throughout our express logistics delivery process, your recipients and senders never change. But for the middle, for example, if you come from area A, then you arrive at transfer station number 1. Then pass through transfer station number 2 and transfer station number 3. Then you end up in region B. Then in it, you will go through a lot of different links. Then on each link, your MAC address will be changed. Just like which transfer station you arrive at in your logistics information. Each stage of this information has a source and a purpose. equivalent to you going from transfer station 1 to transfer station 2. You are now sending a small message. It is also equivalent to reporting your data every time you also has a source and a purpose. This is equivalent to the concept of a small scope transfer, like a MAC. On each link, we will all have a source MAC and a destination MAC. But for our entire data transfer process, we will only have one source IP and one destination IP. Is equivalent to the effective range of the MAC address is relatively small, but the scope of our IP address is valid during the entire transfer. Its address information will not change. It's on our whole one data location, because we will learn the corresponding configuration later. But for the earliest, even if people don't fully understand their scope, but first you have to be clear. Can't distinguish IP from MAC. You need to know what they do. Otherwise it will be difficult to learn. Let me stress again. During a data transfer, MAC address it may change frequently, but the IP address is definitely fixed. This is what we call an IP address. It's a coordinated plan. This is the first concept of our 3 layers. IP address. There is a second concept in the second 3 layers. Routing. Routing means simple. I'll give you an example. Just now I sent a data from here. How can this data finally reach the C company server? This thing is called routing. That is an address for our destination in the future. I was able to query this data. We have a concept called routing table. Query routing table for data forwarding can ensure that the final data, original destination, that is to say, the data is sent. If there is no concept of routing, I actually don't know how to go this route. We will learn a table. Routing table. We query according to the routing table. And forwarded. We can do it. The future arrives on every device in the middle. Note that these are the operator's equipment in the middle. We only need to go through the equipment to check the table. Then locate the next device. Our entire internet transmission. It's a form called a baton. One device to another. To another device. There are several transits along the way. And finally reach the destination. We call it a baton transfer form. Then the baton is to rely on routing. Relays that come and go. Or complete data forwarding. This is a concept we will learn in the future. We will also talk about a basic concept of routing today. It is also a network segment problem. So for IP and MAC, don't think that these 2 parameters are separated. For example, I'm going to communicate. Can only have IP or only MAC. This is not possible. In the future, we will truly deliver effective business data. Both addresses are definitely needed. We will learn a message in the NA phase. Then there is a packet called ARP. In the future, everyone will be exposed to some data. You will find that this data may not have 3 layers. That is, there is no such IP address. But we call data like this. Do not call our future business data. Business data is the future that really carries your business traffic. For example, if you visit Company C on your computer, this data is called business data for Company C. For such data, the top layer of your data is the application layer. Has real data content. Then for such data, either MAC address or IP address. Must have. It's just that we'll